Hi everyone, I'm Kyriaki. I'm a second year PhD student, and today I'm going to talk to you about the storage tanks of the future. Is the world ending? On a planet that's progressively overheating, how much longer do you think we'll be able to survive? The short answer is not much. Scientists predict that if we continue using traditional energy sources in the same rate, by 2050, 1/4 of the Earth will experience extreme droughts and desertification. That is less than 30 years from now. If we want to sustain life in the long term, we need to look for better, cleaner ways to generate energy. Alternatives like wind and solar energy rely too much on the weather conditions, and there are serious challenges in storing this energy for future use. Thankfully, there's another option, natural gas, or better, a renewable version of it called biogas, which is produced from farm waste. It's not only practically infinite, but also offers major reductions on harmful emissions. So this green, abundant energy source might just solve our crisis, but we need to be smart about how we handle it. The issue is its low volumetric density, which means that, like all gases, it tends to spread out, taking up a lot of space. If we were to fill up a tank with biogas, we would need to use extremely high pressures in order to store sufficient amount for transportation. But if we line this tank with a material that can interact with the gas and increase its packing efficiency, then we can store enough gas under ambient conditions. To use this tank in our cars, we need a material that can load and unload the gas on demand, much like a light switch goes from on to off in the push of a button. We call these switching materials, but they're exceptionally rare. Only about 70 of them are known to date. That is where I come in. My research focuses on developing new materials that could potentially render previous storage methods obsolete. Nearly 2 years in my PhD, I've designed and synthesized 2 new families of related switching materials that enable me to do systematic studies, identifying new factors that affect switching, and fine-tune their properties. I'm looking into optimizing their recyclability, working capacity, and gate opening pressure. So far, I've made valuable contributions in a severely underdeveloped but highly impactful field that leads the way to a sustainable, brighter future. Is the world really ending? Surely not. Science has got us covered. Thank you.